So you've sent us a file that was designed in SolidWorks, and as you prefer to use our standalone system, we will look at how we can bring that CAD model that you built in SolidWorks into our standalone product. Okay?
Okay.
So there are several ways you can export your file. You can use STEP, IGES, ParaSolid. You can even do a SAT file format. So we read different wide range of file formats in VisualCAD CAM. So you see that I have the application loaded on my screen.
Yep.
Okay, perfect. Okay, so what I'm going to do here is go into the open dialog on my screen, which is over on the Home tab on the CAD ribbon interface. So VisualCAD offers you a basic set of CAD tools which you can use for quickly creating some geometries like curves, lines and arcs, points. You can do some curve editing, trimming. You can do some basic surface modeling, some solid modeling, and mesh modeling too. So this is not a replacement for your mainstream CAD system, which could be SolidWorks or in any of the CAD system that you're using. This is basically something that will help you create, maybe add some holes or make some, create some geometries that will help you in the machining process. Now, the file translators, what's supported by VisualCAD, or you can bring in, DXF, DWG files, IGES. You can bring in mesh models like OBJs. You can bring parasolids, point clouds, native Rhino files, SAT files, SketchUp. You can see STEP, STL. So we have a whole bunch of file formats available in here. So what I've done here is I've exported your file out from SolidWorks as a step. I just did it a couple of minutes ago before the demo. So I'm going to select the step file that you had sent us as a SolidWorks file. So I convert it to a step, and I'm going to select open. And in this process, it's going to basically translate the file and bring it into VisualCAD. So you could choose from one of the different export options in SolidWorks and export the file. So I just chose the standard step format. And here I can switch from one view to the other. So I'm just going to switch to the isometric view, and you can see that the part looks like you have a multi-body part in here. Is that right?
Yes.
Okay. Does it look like the part that you had modeled, and does the translation exporting everything looks correct in here?
Yep.
Okay. So VisualCAD offers you all the graphical tools for viewing, view rotations. You can go to like a multi-view layout. So take a look at it from the multiple views like top, front. You can also resize the views. There's all the controls for zooming in, zooming out. And also we support like a 3D navigation tool, which like a 3D mouse, you can call it, so you can use for viewing and rotation as well. Okay?
Okay.
Now, if you look under the display tab, you have access to different display controls like pan, zoom, or you can even use your controls in here, right mouse button click to rotate a view. You can use the control and right click to do a dynamic zoom, shift and right click to do a pan as well. So all of these controls are available to you in VisualCAD. And you can choose from display styles, wireframe, you can go to shaded display. So all of these controls, they can also be accessed through the heads-up display toolbar right across the top. And of course, you have drawing tools where you can do, create your construction plane, which is basically similar to what you call a sketch plane in SolidWorks. We call it a C plane or construction plane, where you can orient the construction plane to a given view or any rotation to create geometries in CAD. And we have drawing tools, similar to your sketching tools. We have 2D curve modeling tools. We have some basic surfacing tools. We do not get into any filleting of surfaces or chamfering or trimming of surfaces in the CAD modeling. We can still do filleting in the toolpath in general when you generate toolpaths in your CAM product. And of course, we have some solid modeling, mesh modeling, basic dimensioning tools. So all of these analysis tools to measure dimensions or take some measurements, check the diameter, check the size, and all the stuff. In the curve modeling tab, we also have some curve extraction tools. So now let's get started in the demo here. And how would you like to machine this part?
Okay. I'd like to hide all of them except for let's do the punch, the very top part there.
Okay, you want to do the very top part and hide the rest. Is that correct?
Well, no, I changed my mind. Let's do the very bottom part, but it looks like you
Okay.
got an extra bit of so we can hide like the 1, 2, 3, the top 4 bodies.
Okay. So I'll go into the front view, so it makes it easier for me to pick all of these right there. Okay.
Yep.
And then what I'll do is I'll just place them on to another layer in here. So I'll just move them on to, I'll just say I want to move it from the layer it's currently on, which is basically level 0, and then I'll just put it on the default layer, and then I can hide the default layer. So basically, you're only looking at the visibility of, this particular layer, which shows it has about 4 different objects in here. You have one right here.
Yeah.
So you have one over here, and then I can say, select these 2. If I hide them, I can temporarily hide these here, and I'll see that are 2 pieces in here as well.
Okay. Let's hide what you have visible there, and then we'll go back to what you have.
All right, I'll take these and I'll put them back into, so I can right click and go to properties and just say I want to move them from level 0 to the default layer. And now I've hidden them, then I can say show the other ones we hid, so that makes the rest of it visible here.
Okay, so now if you click on the ring on the top here where you're there, hide that one, and then we'll machine what's.
All right, so I'll move this also back to default layer. So
there we go.
We got the part. Okay, perfect. So you can see how easy the tools are for navigation inside of VisualCAD, and it brings it in the same orientation the way you have it modeled. So you're looking down from the top, you have your front, right side isometric. You can also split the views. You can add additional views as well. And you can hide or close these browsers for the layer manager, and you can just access them right from the status bar anytime you wish to. Now, as far as the CAM interface goes, VisualCAD CAM is our standalone product. So we use what is called a plugin architecture, where VisualCAM runs as a plugin inside our homegrown VisualCAD. So even though we call it a standalone product, we use what is called a plugin architecture. So when you install it, it's just one single product. As a user standpoint, you wouldn't see any difference. It's just one single package. So internally, it's developed as using a plugin architecture. So you have the mill module. That's the one that you're looking at over here. So when this is active, you'll see the CAM interface for machining. You have the machining browser over here in the top half, and then the machining objects browser over down in the bottom half of your screen. The machining browser has 2 main tabs. You have the program tab and the simulate tab. And then the objects browser has tools, machining regions. You can create features, knowledge bases. So basically, you work your way left to right as you work through each of these on the machining browser. So the first time you start out with is you define your machining process, whether you're going to be working on a 2-axis, 3-axis, 4 or 5-axis application. So you pick the number of axes you're going to be using for programming this part. So for 2 and 3 axis, you would leave it as 3. The professional configuration includes index and continuous 4-axis. It goes all the way up to 3+2 machining, or also known as index 5-axis machining. So if you just have a 3-axis router and you need to machine the part from multiple orientations, you can do it with the Pro by creating multiple setups. But if the router is capable of 5-axis, then you can orient the head to different orientations and then machine them from different planes or different orientations as well. So that's what's called 3+2 machining or index 5-axis. Now, if your machine tool that you have has a automatic tool changer, we automatically output tool changes, and it calls out, the tool number and then whatever your code, like M6 or whatever it is, to call up the tool. If you're working off of a manual tool changer, you can use the additional option to specify a tool change point. So it just basically moves the tool to that specific XYZ coordinate location. So it just makes it easier for the operator to swap the tools out without having to use the control to go ahead and jog it back to like a specific location.
Right. Okay.
All right. So we define the machine. In the next step, you can select the post processor. This would be the machine tool that you would like to generate your NC files or the G-code output files for. And from your notes, I see that you mentioned about an Axis AXYZ router.
Yeah, that's one of them we write for.
Okay, so we do have several different posts for Axis routers. So If it's using the A2MC controller, you can pick that one. It's just standard axis router. You can select this. And all our posts are fully editable and customizable. So we have a post generator interface that's included directly in the software. We can help you make any changes, edits. That's how we write new posts, customize it. So we will be able to support, machines that read standard G&M codes or ISO G codes. We can create new posts, do a save as, give it a new name, or we can call it Rev1 if you want a few subtle changes put on this here. For example, I can bump up the maximum spindle speed of the machine. I could say this machine can go up to 30,000 RPM, or the feed rate can be set to maybe I can go up to 800 inches per minute, for example. I can set my low values in here. So each of these parameters can be set, customized. The startup block, the tool chain macros, all of these can be updated right in here.
Perfect.
And you can have multiple variations of the same post created, and they'll all appear in the list, or you can save it in like a shareable folder. So if you have multiple users trying to use the software from different computers, you can have it in a common place where everybody has access to the same post processor.
Okay.
And the posted file extension, you can specify it to be nc.cnc.text.tab, whatever is the flavor of the extension that your machine or controller expects. The content of the file will still be the same, it's just the extension will be different. That would be most ideal for your machine tool.
Okay.
And by default, we'll display the code in a notepad, which could be a text editor. If you're using your own NC editor, if you have one, you can just have it point to that executable file, and it'll just basically preview or display it once it's posted in that particular application.
Oh, great. Good. Okay.
Okay. All right. So we've defined the machine. We've selected the post processor in here. In the next step, before we define our stock, we want to make sure that the part is in the intended orientation for machining. Typically on routers, you may have more travel on the y-axis. Most routers are built that way, but some routers have more travel on the x. So by looking at the part, looking down on the from the top view, you want to determine if the part, the way it's currently oriented, will it fit into the work envelope of your router. So if I go in and check the create writer define a stock in here, it gives me a length, which is the distance on the x-axis is about 35 inches, close to 36 inches, and the width was about 20 inches, and the height or thickness is about 1.085. So would you like to go ahead with this orientation, or do you want to have the part rotated so it fits better on your router? That's something you want to determine at this point of time, just to make it easier for your programming workflow.
No, this is fine, but when we're dealing with this stock box, what I do is put the part like 50 thousandths below, like the highest part of the part, about 50 thousandths below. Like say it's a 1-inch thick piece of plastic we're going to machine this out of. And I want the part to be like 50 thousandths below the top surface of that 1 inch.
Okay, all right. So the stock is 1.085. So you said you're going to be using a 1-inch stock?
Oh, that's the height of the part? Okay,
yeah,
let's
that's the height of the part,
what it meant. Okay, let's use 1.5-inch stock, and then let's place the part 50 thousandths from below the surface of the stock.
I can certainly do that. Now, how about your length and the width?
Let's put 3/4 of an inch extra on all sides.
Okay, so one of the nicer ways we could do it here is you could either use a box stock where you can define the length, width, and the height, or you could do like a part box stock where you can just specify an offset in each axis X, Y, and Z. So here you said you want to do 3/4 inch on each side, right? Is that correct?
Right. Yep.
So I'm going to add 1.5 inches. So basically it'll add 3/4 for each side. I'm going to do the same thing. I'll say plus add 1.5 inches. So that basically is 3/4 times 2, and then I'll leave this as 1.5, and I'll pick OK here. And you'll notice that the stock is now larger than the part, and it's basically right now it's locked to the lower left corner. So if you want to do what is called an align stock, so right now in the align stock, I'm going to have it flush to the center in X and Y, and right now the top of the stock is flush to the top of the part. So we'll lower the part down by 50 thousandths in the Z once we've done this step. Okay?
Okay.
All right, now this is one of the ways to do it. There are several other ways you can do it here. One of the other possible ways I could think of is I can create a small line or a surface that's 50 thousandths thick, and I can basically use that. Or the simplest way is select the entire part, and I can transform it, or I can use what is called a graphical manipulator in here. I can just pick the Z-axis arrow and say I want to drop it down by minus 50 thousandths. So it's basically going to drop the top face of the stock down, so the part is 50 thousandths below the top surface of the stock.
Okay.
All right. Any questions so far, sir?
Looks good.
Okay. So now if you hit save, it'll automatically save all of this information to your file. You can pick a folder where you want this to be saved. So I can hit the save button in here. I can just go pick a folder where I would like this to be saved. I'm just going to hit save button right there. So it saves this in a VisualCAD file format, and when you reload this part, all of this information will be loaded back. So the stocks that you define, the tool, the feeds and speed, sorry, the machine definition, the post processor, all of this is basically saved. In the next step, we want to establish our XYZ origin. We call this as either you can do it in a couple of different ways. We can move the entire stock and the part to the origin location. So basically everything gets translated or transformed, or we can use a feature called work zero, which allows you to actually move the coordinate system origin for machining to any specific location on the stock. So you can pick whether you want to put it to like a southwest corner, top of the stock material, or bottom in the Z. So you can pick where you want to put the XYZ origin. Would you have a preference on where you'd like to put it?
Since we're doing the XYZ, let's go to the bottom of the stock in the southwest corner.
Okay, lower Z, southwest. So if I take a look at it from the front view, you'll see that it's going to be set right here. Now the CAD world coordinate system origin still remains here. We're just moving the origin for machining over here. So this could be like, and some machine tools could be like a G54, your work offset. If the controller would like to use a G54, you can enable that right here and then pick generate. So now your machining origin is over here, your CAD origin still remains. We do also have the option where you move the entire part and the stock to the world coordinate origin as well. So you have the choice of how you want to do it.
Okay. Well, this looks good. The CAD origin is really doesn't matter, right, at this point?
That is correct, because all the toolpaths you generate will be referenced off, the coordinates will be referenced off this particular point.
Okay, good.
All right. Okay, so next we are ready to program some toolpaths. So we want to define some tools. You can see that I currently have a library of tools created in here. So VisualMILL supports different types of tools, starting with ball mills, flat mills, corner radius, tools for engraving, chamfer, taper, thread mills, face mill, dovetail cutters, fillet mill tools, lollipop cutters. You can also do form tools, so you can basically draw the profile of the tool, one half of the profile, and then we can revolve it here to define as a tool. And then you have drill, center drill, reamer, tap, bore, and reverse bore. Each of these tool tabs can be defined, and you can see that I have different sizes for the tools defined by defining the tool dimensions in here. If the tool is being previewed, you can set your tool numbers that maps up to your automatic tool changer, select the material type for your tool. If you're doing any metalworking, you can also pick the coolant types. You can input any comments like where you source your tools. This can be output in the code. And of course, you can set your feeds and speeds. The feeds and speeds can also be determined based on the material you're working with. So we have a handful of materials in the list. The list can be customized to add additional material types, and based on the material that you pick and the information that you specified for the surface feed and the feed per tooth, we have a built-in feeds and speeds calculator in here, and this can help you determine feeds and speeds. So you can also put in what is the maximum RPM of your machine tool, maximum cut feed rate your machine tool can handle. So all of this can be input right in here. So, and then this will help you determine your feeds and speeds. Okay. All right, so you can go about defining each and every tool type in here. For each tools right there, flat mill, ball mill, you can do that. So I currently have a library of tools defined in here, and it'll automatically load the last loaded tool library. You can have one or more libraries. You can share the tool library, put on a shareable folder, so all of your programmers can have access to the same library. If you want to make a change, update, you update it and just go back and resave it, like how you resave a document.
Okay.
Okay. Any questions so far?
Like say, can we analyze or measure the model, like, find a radius point or something so it can help me determine what is the proper tool to, what would be the best tool to machine this with?
Absolutely, we can do that. So for example, we have different analysis tool here. I can do analyze, and I can say I want to measure like a 3-vertex diameter, and I can choose like object snaps in here. I can say I want to use the near snap. I'm going to go over here, and you can see that I'm measuring just like a 3-point arc. It says that's 1.29. Or I can go over here, say 3-vertex diameter in here again, and I can just pick 3 points right here, 5.238. We can also measure, extract some curves from the model. That's a nice tool here. I can go into the curve extraction tools. I can also use layers similar to how we have layering in other CAD systems. I can insert a new layer. I can assign a different color for the layer, and I can go ahead and extract some curves. I can say I want to extract curves that are on this particular face. And when I do that, it automatically creates these geometries. It says there's a circle. So when I pick the circle, I can go to analyze and say arc diameter. It tells me that it's 0.3125 in diameter. So I can extract, I can also identify the center point for the circle. If I hover the cursor, use the object snap and pick center, and I can measure the center of the circle. So we have, standard measurement tools. I can measure distance between 2 centers, arc centers. I could say I want to measure between this over here and this over here, and it tells me the distance between the 2 arc centers is 2.886.
Okay.
Okay. So you have
Now,
tools for measurement.
Okay.
Go ahead.
This base here, do you see my cursor moving?
I will go ahead and give you access to drive my computer, and you will be able to move the cursor in here as well.
Okay. Okay. Right in here. Can we figure out the width here?
Absolutely. So what I'm going to use is a tool called distance, minimum distance between 2 points. And I can use what is called a near object snap. So snap to 2 points that are close enough right here, 1 and 2. So that's about 0.189. So if you have a 3/16 bit, you might be able to get in there, or maybe you can go slightly smaller than that. So you do distance measurement. You can pick 2 points near these two, and you'll see the distance between the 2 points that you picked in the right above the command window.
Okay, good. All right.
All right. Okay. So are we ready to start putting some toolpaths on this part here?
Sure. When we were zoomed in, I thought it was faceted. Is that just a display thing? Or is it...
Part of it is a display, and part of it is also how we translated the file in. So we have controls to tighten the faceting tolerance. So the smaller the number you put in, it brings in a much tighter accuracy. So you can tighten this up when you read it in. So when you bring in the step file, so this was the default tolerance in here. So we can tighten it up further and bring it in as well.
Oh, okay.
Okay, so you have controls for this. And also the display can do flat shading or smooth shading. So if you switch to smooth shading, display looks a lot smoother. If you put it to flat shading, you'll see if there are any facets. Then you can go back when you re-import it. You can bring it with a much tighter tolerance.
Okay.
Okay.
And that's really just what you display right there. Okay.
Well, this will be what you see when you machine it, actually. So you want to go back and import it with a much tighter tolerance.
Okay, very good.
So I can change this back from a 2 thou to a 1/10,000th of a tolerance, and then I can bring it in. So it'll, reduce those facets, make them much smaller. Okay.
Okay. All right.
All right.
Now I had a question. See, we've got a huge library of parts that we've done, and we save it as the SolidWorks, and we also save it as a Parasolid. One for redundancy, and also so we can bring that into other CAM software. And when I brought up, and we have to use like version 15, so it's not the most, up-to-date Parasolid. But when I brought it into my demo mode, it took quite a long time, like maybe 5 minutes for it to load in. and it had a couple of artifacts, like it just had like a stray vector line in there, and I didn't try to machine it. I don't know if it would affect it or not. But see, that the nice thing, because there's more than just one person machining this, so if I design something and then save it as a parasolid, I'd like to stay with that format, so it could be machined by any of the CAM software that's available to us,
Yeah, so we do read parasolids, but if there is an issue that you run into in terms of translation, I would definitely recommend using one of the other export formats, which could be STEP. STEP also has STEP is a more recent format over IGES, so you could use STEP. That's what I did here. So, but if you're welcome to send us the. We can take a look at the parasolid file and see what could be causing the issue, and we can probably have it. Have development review that and see if there's something they can do to improve that.
Okay, I guess it's not a big deal. It's just I try to continue the current workflow.
Okay, yeah, STEP would work. If you have an issue with one translation, sometimes it could be some geometry specific that could be causing it, and to eliminate that, I would recommend trying one of the other formats. Maybe you can have a STEP and parasolid exported out and saved in your folders. So if there is an issue with parasolid, then at least you have a fallback plan to use STEP.
Okay.
Okay, now let's go ahead and look at some of the tools. So I see that you had sent me some summary of tools. Your 3/4 inch tool was a tool number 7 in here. So I have a 3/4 inch end mill. I can just go ahead and change the tool numbers, your height offset register, and then if you want to do a diameter or cutter compensation, you can set those, and you can just update the tool library in here. You can also change the name of the tool. You can add comments in here, so you can put all this information right there. So that's how easy it is to update your tools. Now let's go ahead and start some tool paths in here. We'll do a facing operation or a roughing operation to start with, right? You want to face this entire block, or we could just face just the boundary around the part in here to bring it down to this height, right? There's different ways we can do it. So if you just want to face it down on this area, we will go into what's called 2-axis. We have different methods available, starting with roughing, facing, pocketing, profiling, all the way up to remachining in 2-axis. In the Pro, you also have remachining in 2-axis. That's one of the added features of the benefits of the Pro. In 3-axis, you have access to all of the advanced 3D methods in the Pro. The standard and expert are limited to 5 different types of 3D methods. The 4-axis methods are included in the Pro. You also have access to whole machining. The simultaneous 5-axis is not in the Pro. You can still do indexed 5-axis where you can do positional or 3+2 machining. And the Pro also includes fixture offset programming. You can do instancing where you can basically have like a pattern of these parts, like an XY instance of these parts created. So you just program toolpaths in one and then you instance the rest.
Okay.
Okay, so we'll start with the facing operation in here. So you can do 2-axis and facing. And over here in 2-axis operations, in most operations, you have to pick a geometry or a feature like a part region that you want to machine. So I could say select curve regions. I can just go grab this boundary here. I can either select a edge from the solid model, or I can, since I have a curve, I can just pick that one right there. That's selected. Right click to accept your selections. You can go pick a tool. So I could say you want to use a face mill cutter. If you have a face mill, you can use that, or you just want to use a 3/4 inch end mill, you can use a 3/4 inch end mill. Set your feeds and speeds. You can put in the clearance. You can see when you select the clearance tab, it automatically displays the safety plane, and you can change this height in here. If you wanted to have any, if you don't have a vacuum holding, you have some clamps, you want to clear it further higher up, you can say you want to go 3/4 inch above the stock. You can set the clearance height. And then in the roughing, you can specify your roughing parameters. How do you want the cut patterns to be in the facing operation? You can go linear. You can do island offset cut pattern. You can specify like a step over in here. You can control the cut depths. So you could say you want to start at the top of the stock and go down. So you want to start at 1.5 inches, go down 50 thousandths. Or here I can just say my depth is 50 thousandths and not cut below this area in here. Set my entry and exit to do a lead in and lead out, how you want the cutter to lead in, lead out. You can specify all of those parameters in here. You can also do arc fitting on the toolpaths, so it'll output GO2s or GO3s and get your facing toolpaths. I can see I chose the offset pattern, and it's entering from the side over here. So when you go to the Simulate tab, you can run a verification, and it's only cutting around the contour of the shape, not the entire rectangular sheet. So we can also do the cut the entire rectangular sheet as well.
Okay.
So at any time you can.
Coil in?
I'm sorry?
Can we helicoil in or ramp in or?
Yeah, so what I did here was I used just a linear entry in here for the facing. I could go back and edit the facing parameters. I can choose a long path, and I can specify an angle and a height on the facing. So it basically comes in down at an angle right there on the facing.
Okay.
In the case of pocketing, you can do a ramp, helical ramp, linear ramps. There's different types in here. In the facing operation, it's either like a 2D entry, or you could do a long path ramp on the facing.
Okay.
You can anytime do a pause, simulate to end. That gives you the simulation of the facing. And we can also apply different colors. You can apply based on each operation. You can specify a color for the simulation. So just way it makes it easier for you to view and analyze it here. So you can see that for the facing, I picked the color. When you go back and run the simulation, you can see the color changes as the cut material color.
Okay.
Any questions so far?
No, we're good.
Okay, perfect. So then in the next step, you want to go ahead and take care of machining these holes in here. I know we measured the diameter of the holes. These were, if I go back and verify it here, analyze that arc diameter, they were 0.3125. So would you have a drill bit of that size, or would you do like a pocket machining, or how would you like to go about machining those?
We would drill it probably like 3/16 or something, and then after it was machined, just for hold down purposes, if we wanted to. We do have a vacuum table on that one, but just anything, and then we would just manually blow it out to the proper.
So we can go ahead and use a hole machining, a drilling operation in here, and sure. I can actually use select drill points and circles, and I'm just going to go ahead and choose here. I can say select by layer, and I'm going to just grab this layer in here. It picks all the geometries that are on the layer. And I only want to pick the holes and circles, so I can put in a filter in here saying only pick all the holes that are up to 0.32. So it automatically filters out the rest. I have 11 holes selected. I can go ahead and pick a tool for it here. So I can say I want to use a 1/4" drill, for example, right? Or I can even use an end mill for drilling. I don't have to go with a drill bit. If I want to use a 1/4" end mill, I can just go ahead and say this is the end mill that I would like to use. It's a carbide end mill. Set the tool number as 2, specify the material here, do a save it as the tool, and I can use this tool for my drilling operation, set my feed speeds, clearance, cut parameters. I can choose whether I want to do standard drill or like a deep drill, which is like a peck drill, or brake chip. We have different drill types. You can specify the depth that you want to drill. So since this is a through, I can actually pick the depth from the 3D model. So I can just pick 2 points, a point near the top edge, a point anywhere near the bottom edge. Measures the total height right there, and I can say I want to go past. If you had a drill bit, then you want to tip to clear. You can say add tool tip to drill depth. In this case, there's no tip because it's a flat end mill. So I'm not going to select that option. Then sorting, you can specify how you want to go in the sequence. I can say starting from the lower left corner, and that basically produces your drilling tool path. It goes in a sequence from one to the other. Now again, you can go to the Simulate tab. You can apply a different color by going to properties in here for the drilling, and I'm going to pick a different color in here. I'll just pick blue, then pick simulate. So you can see the holes are now being drilled right in here. And depending on the thickness, since the stock is 1.5 inch thick, and we left only 50 thousandths above, so we're not going all the way through as you see it. So if you want to go all the way through, I can go back in here and change my depth to 1.5 minus 50 thousandths, right?
Yep.
Be 1.45, and I updated the toolpath, and now you'll notice that it is going to go all the way through, as you see it in the bottom.
Yes. Yep.
All right. So the drilling is done. The next step is basically you want to mill the pocket the areas on the inside out, right?
Yep.
So there are different ways you can do it. Since you have some radii in these areas, you can do a 3-axis operation, or if you just want to do like a 2.5D operation, you can do a 2.5 axis. I would probably do a 3-axis, like a Z-level or a horizontal roughing operation in here. So just go into 3-axis, start with the roughing process. And again, I can pick a boundary in here. I could say this is the area I would like to keep my cutter inside. So the toolpath tool will stay completely inside this. I can specify a tool that I would like to use for it. I can start with a 1/2 inch end mill or a 3/4 end mill to start with. Would you have a preference?
Let's go. How we do is we go as big as fast as we can. We do like a high-speed strategy, and so we helicoil in to like within 20 thousandths, 50 thousandths of the final surface, and then rough it at like 48% to 600 inches or
And
something.
what tool would you like to use for it, sir?
3/4.
3/4. Okay, so we'll pick the 3/4. We'll set the cut parameters here. So here in the cutting conditions, you have core and cavity regions. You can pick the cut pattern if you want to do the high-speed cut pattern, which uses constant tangential arcs. So it basically, the tool path, what it forms is a tangential arc rather than using an offset pattern. And it allows you to run it at how much higher feed rates, prolongs your tool life. So I'll show you the offset, and then we'll switch over to high speed as well. You can see the difference between the two methods. And then you can specify your cut level containments, where you can specify how fine you want the cutter to step into Z. You can also control your step overs right in here. You can specify whether you want to go like 48% or 50% or whatever the step over that you want to put in, the tool diameter, and step down how much of material you want to take down per pass. I could say 30% or 40%, right? So for example, I could say 40% of my tool diameter is how much I want to remove per cut. Specify the engage and retract, where you can do a helical in for the pocket. You can specify a radius for the helix. You can give it a height in here for the helical height, and then the angle that you want to use. And then you can also apply arc fitting to the tool paths in here. We have controls for all of these, and then you pick generate. So in this process, it's actually going to compute a 3-axis roughing toolpath, which takes into account the part and the stock, and it creates a toolpath right there. That's your offset cut pattern, as you notice it right there.
Okay. Now, silly question: if the Z depth, if I put in just like 0.8, but it would look at a solid model. No,
it will look. It will be looking at the solid model, so it can't go past that the distance, and it's not going to be able to do it. If you want to do like a 2D pocket operation, then we can specify the depth and how far we want it to go. So for example, if I say 2-axis pocket machining, and I can say this is I want to just pick that area right there, right? That's the area you want to pocket. And I can also go ahead and pick this inside area in here as well. I can pick this one and this one as well. I can do a pocket by selecting all these 3 areas, use a 3/4 inch tool. I can specify and say I want to leave stock maybe 25 thousandths from the sides, use a cutting pattern in here. Now here I can specify the depth. Cut levels, I could say I want to start at this particular height, and that's where I would like to start. And then I want to go from here down to the bottom edge. So that's about 0.335. And if you go put in deeper, it'll be cutting deeper than this, because you're using, it will, when you do 2D operation, because you're manually setting the depth, how deep you want to cut. If you do a 3-axis operation, the depth is determined based on the model automatically.
Okay.
You have control. If you want to go slightly deeper, you can do that. If you want to break it in multiple steps, you can absolutely do it. And you can control all of these settings here. You can say you want a ramp. You can specify your radius. You can specify the height. You can specify the angle. You can apply these for each cut level. And of course, you can do true arc fitting in here as well, and then generate the path. So that will give you a 2-axis operation. So you can see that this is a 2D operation, and this one is a 3-axis operation. So in 3D, it's automatically determining all of the parameters. In 2-axis, you can manually specify how deep you want to cut. So you have all of the control. Now, if you want to change this from a offset cut pattern, so this, we call this an offset pattern. We also have what is called a high-speed pattern in here, high-speed cut pattern, which basically generates constant tangential arcs. You can apply the high-speed cut pattern as well. So this allows you to run at a much higher feed rates. And there's your high-speed cutting pattern right there.
Okay.
And if for any reason it's too tight, the cutter can't get in there, you'll notice that the tool is not able to get into those areas in either a high-speed cut pattern or one of the other patterns.
Right.
So you can see the nice tangential arcs being generated right in here.
Okay. So it looks like it's set to either climb or conventional. It doesn't zigzag or.
Yeah, so in the high-speed cut pattern, you have the option to either do climb or conventional only. If you pick the offset pattern, then you can do mixed, and
Okay.
you can use the mixed cut pattern in the offset
Okay.
pattern or linear pattern. So this here, it's doing a mixed cut pattern as you go between one to the other. So let me go ahead and run a verification, and we could take a look at it. So I'm going to do a simulate. Before I do it, I'll just apply a different color for the simulation just to make it easier. I'll put in lime as the color, hit play, and you'll notice that the pockets are being machined, and it automatically creates a ramp for each of those areas. And it's doing a mixed cut pattern.
Okay.
And anytime you can do a pause, pick simulate to end. Now you are noticing that there are some areas where the pocket was unable to, the tool was unable to machine those pockets. Now for those areas, with the Pro, you can use this method called 2-axis and remachining over here, and I can select the same set of boundaries. So in this example, I'm just using flat areas. I could have extracted some curves as well. Now I can go from a 3/4 inch to maybe a 1/4 inch tool, right, to clean up some of those tighter areas. And then use the same type of parameters in here. Specify the stock to leave. You can specify the previous reference operation as a pocketing. We used a 3/4 inch tool, or if I want to have a little bit of overlap, I can say I want to put in maybe 0.8, add 50 thousandths slack to it. Specify my step over in here, cut direction, cut levels. You just want to do it in one cut. I can say it's at the bottom what I chose. You can also apply the entry and exit. You can do a long path ramps wherever you need to. And you can also do arc fitting in here as well. So it'll generate true arcs. So now when I generate this tool path, it's going to create a remachining operation, and it looks at the areas where the previous cutter could not get in there. And it generates a tool path for those areas. Now, what you're noticing here is, it's creating those tool paths in those areas, and it's cleaning them up for you. And you can also specify where you want to begin the cuts, how far you want it to go. You can, you can display the tool paths right there, what you're seeing. You can go back in here, make any changes that you need to. Like, for example, you want to change some of the parameters in here. You can, update it. And you can always go back and regenerate the tool paths in here. Now, on the pocketing operation, I did leave some stock over there. So I can go back and clean that up as well. Or if you just want to run a profile operation in here, you can do it as well. So if I go back into this operation in here in the pocket, I have set a stock to leave of 25 thousandths. I can zero it out. So it probably will be able to get even closer to the geometry in a lot of these areas, as you noticed it.
Okay.
Right?
Yeah.
Yeah. So if you want to use machining regions, you can go to the curve tab. You can extract these regions from the model. I can pick a face, so it'll extract the regions from the 3D model. I can do the same thing by picking this one here and also picking this one here. So now on the remachining operation, I can go back and say, rather than picking a flat area, I can pick these curve regions around here for the remachining toolpath. So you can see there's different ways how you can select your boundaries for machining. So you can either pick curve areas right here as I'm selecting it. So you can see in this case, I have to go and select curves around each of these regions, right? So I can place them on a different layer, and I could do what is called select by select by layer. And you can select all of those geometries right there, as I just did.
Okay.
I can go back and also add additional geometries in here. So that gives you the control. Over here, you can pick a tool. You want to go with a 1/2 inch, a 1/4 inch, or I can even go with a 1/8 inch cutter. I can specify where I want to begin my cuts. So very similar to what we did in the previous operation. Go from here down to this level, right? So I can specify each of the parameters and then pick generate. That'll create the tool path. So to go and clean up those areas where the previous cutter could not get into. So you can use a remachining operation for that. You can also have the control to suppress operations. So you do suppress, you can suppress it. Or if you want to go back and use a smaller tool, or you could even do like a 3-axis operation in here to go back and clean up some of the areas. So if you want to do a 3D approach, I can use a 3D approach, 3-axis method instead of using a 2.5-axis operation in here, where I can specify the tolerances, the start to leave over here. I can also do what's called a cleanup of the flats in here. And I can specify the top where I want to begin my cutting from. So the 3D gives you automatic control for establishing all the parameters in here, where you don't have to go back and set any of the, you don't have to pick the depth and all that stuff. And this gives you a lot of nice controls. So you can start with a 3-axis. You don't have to do a 2-axis operation. You can go directly with a 3-axis operation.
Okay. So now on finishing, can I tell the tool to remain down?
Yeah, so we have in the operations in the roughing, we have the option to do a cleanup pass and always keep the cutter down. So it'll do the best possible not to retract the cutter when you go from one area to the other.
Right, okay.
So it'll do its best. If it's possible to find a route to make it, it'll, when areas get pinched out, it'll try to keep the cutter within the same area and not avoid the retracts wherever it's feasible.
Okay.
If it has to retract, it'll do the minimum retract and then it'll again ramp back in as you're seeing it. So over here, I did a roughing operation. Now, the beauty of the 3-axis methods is after you do a roughing, I can go back and do what is called a 3-axis re-roughing. So very similar to how we did remachining in 2.5-axis, we have re-roughing in 3-axis. I can go with a smaller tool, a 1/4 inch or 1/8 inch end mill. I can specify my parameters in here. I could say, now I want to take it to leave the same amount of stock in here, use the same cut patterns, what I had, do a cleanup pass as well. And then in the cut levels, I could specify the depth control. So where I want it to start, I can specify that. And I can say I want to do a cleanup of the flat as well and do additional cut parameters in here. So this will allow me to go back and machine only the areas that were uncut. So if you look at the roughing operation we did here, there were some areas that the cutter could not get in, right?
Mm-hmm. Yep.
So I can go back and re-rough it with a smaller tool. So this will automatically take that into account.
Great. So we can't currently do that.
In your system, the one that you're working with. So here you can see that you can go back and do a re-roughing. You can also do not do the cleanup of the flats, and we can use a different technique to do a cleanup of the flats in here as well. So there's a lot of control available as you see right there.
Okay.
And you can do a simulate to end, which runs through the simulation. And you can see how nicely it cleaned it up for you right there.
Good.
Okay, so the next step is you want to do a finishing. So you can either do a combination of like 2D methods, like profiling or profiling to clean up around the wall. So I can use a 2-axis and I do a profile to have it automatically go around the walls of the part. So for example, to select those features, I can actually just hide the model in here and do a select by dragging a window around it. So I can choose basically says select the curves I would like to machine, and I'm going to just drag a window to select all of these in here and drop the ones I don't want it to be used or participated in machining. So I'm going to pick these areas in here and select those. So I have those selected now. I can use the smaller tool, the 1/4 inch tool, and I can do a profile cut. I can do climb or mixed cut, choose inside or outside, or here I'm going to say determine the side to cut based on the 3D model. So it automatically figures out which side to place the cutter. And I can specify multiple depths if necessary, specify the ramp, and do arc fitting and apply a sorting to use the minimum distance. So in this technique, we are basically running a profile cut to go around and clean up around each of those areas automatically, and you have the control, the finest control that you need in here. So you see that it goes around and does a profile. And you can always set the depth, all the parameters in here. You can go back, edit the operation, cut levels. You could say you want to start over here, and then you want to go from here down to this bottom edge. And you can break it up into multiple passes if you need to, or just do it in one cut. So that gives you all of the detailed control to go about machining it. So that gives you the profile pass around it. Now, if you want to change the tool, if you feel that a 1/4 inch, you want to use a 1/8, you just take the tool, drag and drop it on the operation, right click and regenerate it. Your toolpaths are now updated. You can go back and rerun the verification. So that's how easy it is to work with it.
Good.
All right. So now let's take a look at how we can machine these sculpted areas or sculpted features. So we can do different techniques. We could start with a Z-level operation. We call it a horizontal finishing operation. I could use that to start with it. I can just pick a boundary and say machine all the steep areas inside the section, and we can go with the radius tool. So we can use a 1/4 inch or 1/8 inch ball nose cutter. So I can use a 1/4 inch ball mill, and I see that you have one which has a so you have a bull nose cutter. So I'm going to call this a corner radius. That's what we call a bull nose. It's a corner radius tool, and you have a 0.06 corner radius in here. And I'm going to specify this tool right there, and I can specify a tool number for it that matches what you have in your tool changer. So this will be tool 4. And I can do a save as new tool. The tool is defined. I can use the cut conditions where you can specify your cut levels. You can specify cut containments. You can control the step down, how fine you want the cutter to step. You can also go and clean up, put a toolpath to clean up the flat if necessary. And you can also do any additional options in here and then pick generate. So you have a lot of options and control that is available to you in VisualMILL. The Pro configurations offers more advanced 3-axis machining methods. You're not just limited to parallel finishing or horizontal finishing. So this is a Z-level finishing. As you notice here, it's doing a constant Z-level finishing. So it goes around each of those contours. It's even doing the outermost contour. If you want to exclude the outermost contour, I can pick a region that's slightly offset from the outer edge, and that'll automatically avoid that from being cleaned up again. So there's the horizontal finishing toolpath. And we can go back and apply other toolpath methods. So for example, in this area here, I can pick this and use a method called 3-axis 3D offset pocketing. So this is known as a constant step over machining, or also known as constant scallop machining method. And you can use this by picking boundaries. You can choose, you want to start inside, work your way towards the model. You can specify a step over. So that'll create a constant 3D step over machining toolpath method. So look at the very fine details that you can achieve with the toolpath method. So that's called 3D offset pocketing, and I can apply it to multiple different operations, multiple different features. I can go back in here and repick. I could say I want to apply it to this geometry right in here. I can pick this and this, and I can apply it to that. We also have methods like called between curve machining. So the toolpath will actually morph or flow between the two curves. So there are several different techniques how we can create the toolpath. So I will give you a quick overview of the between two curves, where I can pick a curve and define them as machining regions in here. So this will allow me to pick the start point and the direction for the curves. So I'm going to create 2 curve regions in here by selecting these 2. And you can see there's 2 curves, but the 2 curves are flowing in opposite directions. So I'm going to take this one and move the start point somewhere closer to this right here, closer to the other one, line it up right there. And if you take a look at this, they're right by each other right there, but I need to flip the direction, reverse the direction of one of these curves. So I want to make sure both of them are flowing in the same direction. So now I will generate what is called a 3-axis between 2 curve machining, and I will select these 2 curve regions in here, and we'll still use the same tool, and I can specify a step over in here. So the toolpath will actually flow between the 2 curves. So it uses the 2 curves for the pattern of the toolpath, but then it's projected down to the 3D model. It follows along the 3D model. So you have different ways, different techniques from which how we can machine this part. You can control the step overs. You have a lot of different options how you can do it. So you can see, notice right there, you can select these chain of curves as well by using curve edge regions in here. I can pick, I can use the shift key and select the chain of edges in here around the model. So you can select the entire chain, as you notice it right there. And I can go back in here and select this chain around the model as well. And now I can generate the between two curve machining toolpath, so that toolpath will flow between the two curves. So there are several different ways how these toolpaths can be generated.
Okay, I noticed on your right, see on the upper left-hand corner of that pocket?
Yeah, the curves are twisted in the region, so I need to go back and redo the curve regions that are a little bit twisted. So let me show you how I can correct them, and you can go back and machine it very efficiently here. So if you notice these curves in here, each of these curves have a direction and the start point. So I can display those two curve direction and start points in here. As you notice it right here, let me go back to this layer, hide this one right here. So I need to move the start point and the direction so they flow in the same area. So for example, I pick this one here. I'm going to go to curve modeling, move the start point over. I'm lining it up right here. And I'll pick this curve and I'll reverse the direction of the curve. This reverse direction right there. So now I reversed it. I will go back into this between two curve machining operation in here. And I'm going to select the curves. We'll pick this one right here. And we'll pick the one on the inside right there. So the two curves are flowing in the same direction. So now when you generate the toolpath, it's just going to be between these two and not cutting in there.
And it's cutting that face as well? Oh, no, here we go. Okay.
Yeah, the face was already machined in the pocket operation, so you can see how nicely it's flowing between the two.
Okay. Now, when it comes over, is it like a constant Z step down, or as the contour changes, it changes the step?
It maintains a uniform step over here. It's flowing, it's using between two curves. It's morphing between the two curves. That's a uniform step over. So if you do the 3D offset pocketing, then this is a constant scallop machining or constant 3D step over, this one.
Okay. All right.
So there's different techniques on how you want to machine it.
Okay. And so on the parallel finishing, which is what I probably use most,
it's a constant XY step over. So if you do a parallel finishing on the same set of areas in here, do a parallel finishing, we'll grab the same tool, we'll use a similar cutting conditions in here. So it basically does a rastering back and forth following the 3D model. So you'll see that when you have areas that are going across, you may have to go, you'll end up with more scalloping in here. So you may have to change the direction, change the angle from, for example, 0 to 90, so cut across to be able to, eliminate some of those scalloping.
Okay. Yeah. I misspoke. I meant because we don't have this parallel finishing option. We just use Z, and I'm pretty happy with that.
Okay.
So, but I wanted to make sure that there was.
Yeah. So we have Z level finishing, parallel finishing, 3D offset pocketing, between curve machining. So there's a lot of different ways how we can do it.
Okay. So in summary, then the horizontal finishing will do a constant step over, or
constant Z. Constant Z. So in the case of horizontal finishing, when you have areas that are not too steep, shallow, you wouldn't see cutting over there. So if you do the 3D offset pocketing, then this is a constant 3D step over. So it does X, Y, and Z, not just X, Y, or Z.
Right, and that's what I want right there. Is that kind of.
Yep, this is called 3D offset pocketing, or also known as constant scallop machining or constant step over machining. It's called different ways. Yeah.
Okay.
So you can program all of these features. Once you're done programming, you can, if you want to suppress some of these operations out. So for example, I don't need the parallel finishing. I can select them and do a suppress on it. So those are suppressed out. You can go ahead and take a look at the machining time. Right-click on information will give you estimated time for machining for each of these. So depending on what we put in for the feeds and speeds, so you can see that roughing is taking a lot of time in here. We can go back and optimize it, right? Some of these operations, it gives you, you can re-optimize the time for machining, feeds and speeds. And once you're ready to post it, you right-click and post. You choose where you want it to be saved. Automatically, uses the name of your file for you. And then the posted code will appear in your text editor, which could be Notepad, WordPad, Word, or any text editor, NC editor. You can output it right there.
Okay. Now, when it's in the post, when it's transitioning from one tool to another or one strategy from another, could we have it automatically put a comment in the?
Yeah. So in the post processor, we have the option to output comments. So if you take a look at the posted output file, you will see that the name of the machining operations are being output at the start of each operation. So you can see that the first operation right here.
Okay, good.
And then if I do a search, it shows the next operation is a standard drill, turns off the spindle, grabs the next tool, turns the spindle back on, and there it starts the cutting right there for the drill operation. So you can look at the tool changes, or even if there isn't a tool change, you go from one operation to the other, it'll output a comment for each. And if you want to output any additional comments, you can just go right here. If you want to do like an optional stop, let's say you want to go from one to the other, and you can right-click, go down to properties, you can specify a comment to output. If you want to output as a G code, you can just add a dollar as a prefix sign, so it'll skip the comment characters like the parentheses or whatever that is, and output it just as a regular line of G code.
Okay.
And you had a question about shop documentation. So right click, shop documentation. We have 4 different template types. We have an Excel template as well, and we have additional template types. So you can pick one of these templates, and the templates can be customized. They're using standard HTML, tags. So if you're familiar with XML programming, you'd be able to customize the kind of, modify the cell spacing or width, or you can reorder some of the information in there. So there's some control available in customizing your templates. It outputs a tool list. All of this information comes out in the template. And if you have a print as PDF, if you have a PDF converter or something, you can save it out as a PDF. We do not generate a PDF directly out of the shop doc, but you can do a file, use save as or print to a PDF. So there are several, or probably even open source PDF converters available out there.
Okay.
You can also put the tool list in your G code if you'd like to as well.
Okay, and I can put in my own comments before we generate this shop document,
yes,
or is
if you go into the operation, and if you right click on an operation and go to properties, you can type in a comment here. So use carbide or zero out at southwest corner. So if I put this in here, when I do a shop doc, you will notice that this information is output. So it's cycling through each and every operation in here, and the comment will show up right here. You see that, sir? So you can type in
gotcha.
for each tool, each operation, you can put in a comment. Now I could have put this on the work 0. I just put in the first operation, so just an oversight here.
Okay.
Are there any other questions I can help you?
No, that's good. Now, as far as, like, say we have multiple parts, and I wanted to cut multiple parts out of a single sheet, like say this multi-bodied part, can I move these around, or would I have to kind of just use my brain and do the work offsets on every one of them?
You can have multiple parts laid out in here. You can drag and drop them to arrange them and orient it so the way you want it. You can place them in, define a 4x8 sheet, and you can program all of them at once.
Okay. So the ones that we have hidden here, we can move those around.
Absolutely. Yeah, I can go into, and then I can drop them down in the Z. I can do them. I can place them, pick and place them the way I want it.
Okay.
And one of the nice things I want to point out here is that we have a very powerful feature called knowledge base. So the entire workflow that you did here, if you're working on other parts that have similar workflow, you can take this and save this out to a knowledge base. So it basically saves the entire workflow of operations with the tool, the parameters, the feeds and speeds, the cutting parameters, all the things that you dialed in, it's saved to a knowledge base. And then on the other project, you can just load them back in here, and it'll automatically read all of the information for you. And then you just have to go back and either select some machining geometry or maybe make some finer adjustments and post it out to your machine.
Okay. So on these operations, when the next time I open that dialog, do they have default values or do they just retain what you did last time?
So if you edit one of these, it'll have the values that you put in. If you start out a new operation, it'll load from a default, whatever is the factory default setting. However, you can custom and set your default. So for example, take a look at the roughing operation here. We put in certain parameters in here, right? So if you want this to be as a default, you right click and choose save as default. So it'll write it to the default. So the next time you create a new operation in any project from the menu, it'll load from the defaults that you've created.
Great. Perfect. Okay.
So
Okay.
let's take a quick look at how I can move some of the parts in here, just to give you a quick, overview, so that way you feel, comfortable and confident with it.
Mm-hmm.
So I'm going to go back in here. I have some of these selected. So let's say I want to grab this part right here, right? And I can use the graphical manipulator, and I could say I wanted to drag this over, right? And
Okay.
I can place it wherever I need to. I can select this piece right here, and I can drag it down in the Z to wherever I want to place it. I can even do precise placement. I can say pick this point and put it on Z0 or wherever that needs to be done. So that's how easy it is to move it. So I can now check, I can say this piece, I want to put it back to the other layer. So I can grab all of this in here, and I can change the layer name as well. I can say I want to add a new layer, pick a color for the layer in here. I'll apply green, and then take this component what I've selected, and I'm going to say move it from the default layer to the new layer. So I have the second piece in here, and now with the second piece, I can specify where I want this to be placed. So I can line up, if it's the same thickness in here, I can line it up. So I can say analyze distance. I can go from here and down to the bottommost point. So that's 1.5. As you can see, it's slightly thicker than what the previous part was, right? So I can go back and say I wanted to select this particular part. So I can drag a window to select this one, and now I can say I want to line up the bottom of this part to the bottom of this part. So I can do a transform move, and I'm going to use this move command in here and say pick from point. I want to pick the bottommost point in here. You may have to flip this part over, right? So because okay, so I can pick the bottommost point right there, and then pick 2 point is I want to pick the bottommost point right over here, and I only want to do a Z transformation. So I zero out X and Y, so it automatically puts it in the same Z as the other one. And if you want this to be flipped over, I can select this part and then flip it over by 180 degrees. So I can use the controls using the graphical manipulator. I can say I want to go 180. That's flipped over, and I can move it down in the Z. So you have all of these controls to do it.
Good.
Yeah.
Excellent. Okay.
Do you have any other questions before we wrap up the demonstration?
No, we're pretty good. And actually, do you remember Dave Teeters from Aeromotive? He's got the Rhino version.
Yes. He uses.
Spoke very yeah, he spoke very highly of you. We got him into SolidWorks, and we got him on his router, and he's loving it. And he's telling me all about how awesome Rhino is and how awesome you are.
Thank you. And that definitely helps, right? So you have one of our customers who is using our product every day in their workflow, and you actually see, seeing is believing it. So he's basically proved to you that how happy he is with using our product, and he's a great customer, and we do offer very good technical support. So it's exceptional, one of the industry's best support what we offer here.
Yeah, it seems that way. Okay, good. I think I've got all my concerns